So looking back at our slides, we also see that we can use ACLs with the capture or the purpose of capturing for spanning or monitoring ports in order to basically classify only certain types of traffic coming from a port. So let's actually go out to command line, and the topology that we'll be using for today is fairly simple. We'll use this and then a modification of this for our security and then next our QoS sections. But we have our two Nexus 7Ks and 5Ks, and we're basically going to take a look at just some basic layer 2 and layer 3 access lists. So we're not going to spend a lot of time on just basic access lists. They really haven't changed too much with the obvious addition of, if you're not used to using object groups, for instance, in 6500s or something. But we're going to certainly spend a good amount of time when we get to the security group ACL and TrustSec. So here in our 7K, and we're in the default VDC for 7K2, we can certainly, let's just make sure we have feature interface VLAN in case we want to put an SVI on. We can go through and create IP access list, and we'll just say something like, we'll just give it, let's just say L3 port, and the syntax really hasn't changed at all for standard access lists. So permit, deny, the particular type of traffic that we're going to want to classify, what protocol, is it going to be IP, ICMP, is it going to be a routing protocol, EIGRP or OSPF, are we trying to classify GRE traffic, but whatever it is we want to particularly permit, is it layer 4, TCP or UDP, and of course we can do the same, any, host, and then we can also use this address group. So if we want to use things like address group, this is where we'll go out and we'll first create these address groups with object groups. So we can say object group, and we'll say either IP or version 6. So we'll just create an IPv4, and we'll call it maybe, let's say, servers. And so here within the address group, we can choose that we want to, first of all, let me actually go back. At this point, we can either choose address, so we're basing it on particular layer 3 addresses, or port for IPv4 and 6 TCP UDP ports. So we chose address, we chose servers as our tag or name, and we'll just say something like line 10 is the host of, I don't know, 1.1.1.101 is one server. 20 is host or even entire network of maybe let's say 10.0.0.0/24, something like that. So we'll also create an object group for port, and maybe we'll call this web-based traffic. So we'll say 10 is going to have basically be equal to, greater than, less than, or not equal to, or even a range of ports are our possible options here. So let's say equal to port 80, equal to port 443 for SSL, and I gave it a duplicate sequence number, so we'll say 20, and then 30 maybe is a range. Maybe we want to do some Tomcat ports from 8,000 to 8,999, for instance. So then we'll go back to our IP access list, and let's say layer 3 port, or we could call it something a little more meaningful, probably would, and we could say something like 10 permit, let's say TCP, and we want to say the address group of servers. Actually, let's try this in reverse. Let's do it, let's say web, and then the port group of servers. So I'm actually giving it what should probably be considered an insane argument, and it's going to, the parser is going to correct me and say that the object group within the given name, oops, exists with a different type. All right, sorry. So that's actually not the, so basically what it's saying is that, that the address group, web is not an address group, it's a port group, and servers is not a port group, it's a address group. So that's what we expected. Instead, we want to say address group servers. And I don't remember if that's part of command completion. No, it doesn't. It doesn't bring that into the parser, so you do have to spell it out properly. And then port group of web, so from those to any. Okay, so there we have those. And then we could apply that to any layer 3 port. We could apply it to a no switch port interface, an SVI, port channel, as long as it was routed, etc. Okay, taking a look at VLAN ACLs, we can create VLAN access maps. So let's just call this a VACL map, and we'll give it the sequence of 10. This again is not really any different from Catalyst-based VACLs, if you're familiar with those. So I might match an IP address that I would have probably already created. Let's say I want to match the IP address of, and I have to give it a list name, so we just created a list name. Whoops. Got to hit copy. Let's just say layer 3 port. And then I can give it an action. So my action is going to be forward, drop, or redirect. So maybe I want to say action forward. And then I want to create VLAN access map, VACL map, sequence 20, and I want to say match something else. I would have, of course, already had to create that, an IP or MAC access list. And then I could maybe give it the action of drop, for instance, if I want to permit all traffic and drop all the rest. Okay, or I could just drop everything else by not necessarily matching anything. I can also do something called statistics per entry. So this basically allows me on a VACL, on a VLAN access list, to be able to have a lot more granular ACL logging in that OAL, the optimized access logging. Okay, so keep in mind the statistics per entry for VACLs and the ability to get that granular, a little bit more granular logging. Okay, so, and I didn't have a match rule, so it's just deleting that last line. And then when we want to apply this, we would say VLAN filter, and we would come up and say the name of the VACL that we just created, VACL map, and then apply it to a particular VLAN list. So I actually don't think we have, let's just show VLAN brief. We only have VLAN 1, but if I had more than one VLAN, here's where I could apply it to one or a list of multiple VLANs that I wanted. Okay, also, we mentioned the hardware access list command for update default result permit. So what this does is that, again, if there's not enough TCAM memory in order to write the second ACL above the first to hardware and basically use, well, assuming that you have the same amount of entries, use twice as much TCAM memory, but certainly more to write the second list before the first, and then deassociate or unwrite all the first set of ACEs from the switch on chip or the ASIC, we can result in a permit if the server determines that it can't perform an atomic access list. And this is really done per application. So as I go to apply an ACL to an individual port, it's going to determine if it has the memory to do it, and it will try to be atomic, but if it cannot, then the default is not to permit, but we can certainly allow that. The other option is that we can simply say no hardware access list update atomic. So we can turn off atomic updates altogether, and this is a system-wide global setting. So if we do this, then we have to unassociate the list manually, or it will, as we go and try to apply it, it will take the other one off and then write the new one to the ASIC. So potentially resulting in a security gap and a security policy gap. Also, we talked about ACL-based capture and the fact that, if we want to do hardware access list capture, we can turn that on. It's disabling the logging for all VDCs. Note that we're only doing this in the default VDC, but it's turning on ACLs for the purpose of capturing. We can create our ACL just as we would create any other ACL. Things that we are permitting is the interesting traffic that we want to capture. Things that we are denying, we're not actually denying traffic, but instead we're denying that from being interesting traffic, so it's not captured. And then we would just simply apply this to a particular monitor session. So I'd apply this, let's just go into an ACL. So let's say IP access list cap, and I might say that this is for capture session 1. And I would permit the traffic that was interesting, maybe TCP any equaling 80, maybe permit TCP any equaling 443. So I want to, and then deny IP any, nay. Okay, and so I want to classify, I want to capture web-based traffic, either unencrypted or SSL encrypted. And then I want to apply this to the interface. So I go and apply it to the particular interface. It's not actually blocking traffic because it's noted that it's for a capture session. And then I would go out and let me just exit out here and say monitor session and specify that this monitor session is going to be used for the type of ACL. So give it a monitor session, destination, and I would apply that ACL to the monitor session. So that is one option that we have. Also, something to keep in mind when it refers, or when we are talking about the logging, is that the way that we're going to deal with the logging and look at it, we're going to do, let's go back to the command line, and we're going to do show log IP access list cache. Okay, now we don't have any ACLs applied to anything right now, but one of the things that we want to take a look at is when we look at the logging level, we note that we have two different things that deal with ACL. One is the ACL log, and one is the ACL manager. So the ACL manager is dealing with the ACLs specifically. It's managing the ACLs and logging anything about them. The other is basically the ACL log manager. So it's actually dealing with the separate OAL functionality of the logs itself, and it's managing those processes. So the ACL manager is dealing with the actual applications of the ACL and ACEs to ports and monitoring that process. The ACL log manager is taking care of the logging feature and functions for that particular, for all ACLs, so dealing with that OAL process. Okay, so we can specify, let's say logging level ACL log. Let's say we want to see things at log severity 3, and we want to say ACL log match log level 3. So when we go to look at any of the caching information, we want to, first of all, tell it to log anything that comes in at severity level 3, and then for the actual ACL that we're looking at, for the show log IP access list cache command, we want to match what we're seeing, not only what was written, but what we're seeing at severity level 3. And then we can also not only log to syslog, but we can actually do logging to a particular log file. And so we can specify a log file. So ACL log file, let's say ACL log file. Oops. And then we have to specify, and of course we would say if we wanted to log to that file at the same level that we were just specifying we were going to capture at and match, then severity level 3. Okay, so basically any error levels, we're not quite going down to debugging or even warnings or notifications, but certainly any emergencies, alert, critical, and error level. And then we're going to, we could say show log and the particular log file that we want to take a look at, and we really haven't started logging anything. We can also do a show log IP access list status, and we can see what these 3 parameters that we mentioned in the slides, specifically related to the logging IP access list cache command. So we can specify the number of entries cached in software, the interval at which to write these, or the particular threshold at which we want to update the log file. So there's really not too much that's different in ACL logging than there was in the Catalyst 6500, with a few other things. You know, I mentioned the OAL is the default and really our only option for logging. We can't disable it like we can and is by the default in Cat 6500. We can use this for capturing, so that's very nice. But this really takes care of what we can and need to do in ACLs on the Nexus 7K.